Now, another important consideration that you have, another important idea that you have um, about slope is the fact that when you have whatever slope you calculate, okay, whatever slope you calculate, slopes will have a positive value when line when graph of your equation is going up. Okay, so whenever you see that you're calculating the gradient and it turns out to be positive, also make the visual connection that the graph must be going up. Okay. On the other hand, so as you can see over here, if we can see that the line is going up, right? The line is going up. And also, in order to make an important distinction, it really just depends on how you are looking at the line, right? And the way we determine if it is going, I mean, if because if you look at it from left to right, it is going up, right? But if you look at it from right to left, it's actually going down, right? So you are just supposed to, this just tells you that you're supposed to look at this line from left to right and from not from right to left, because that's where, in which direction the x values are increasing, right? So you are supposed to look at it from left to right and see where the line is going. If it is going up, then the slope is meant to be positive. Okay, so that's like a important visual connection that you need to make. And of course, if slopes if slopes have a negative value, then graph of the equation is going down, again from left to right. Okay, so and you can see that. So whenever they have a negative value, so if you calculate the gradient and it turns out to have a negative sign, then this is what it implies, that the graph the graphs of our equation must be going down. Okay, and we can see that happening right over here, right? This equation is clearly, it's from left to right. If you analyze, it's going down, right? It's going down. So this is if I mean it's not detailed enough, but if you were to calculate a gradient for this, it will surely turn out to be negative. Okay. So now here's our question. Here's our first question. Without calculation, we have to state whether each of the which of these lines, which of these graphs have a positive, have has positive, and which of these has a negative slope. Okay. So again, remember we have to look at it from left to right. Okay. So if you look at, let's say, first of all, for the red line, if you look at it from left to right, the line seems to be going up, right? I mean, think of it as if you have, let's say, you put your finger on this on your screen on this red line at any point, okay, and try to see that as you go from left to right, you would have to step up, right? You would have to step up in order to remain on this line. That means the line is just going up from as you move from left to right, right? So it is going to have, we know for a fact that the gradient, which is the slope, which is represented by m, is going to be positive. Okay. If you just are able to make this visual connection, it is important because, all right. So, and then let's look at the blue line. Well, If you are on the blue line, if you do the same test from left to right, if let's say you are sitting somewhere over here, and if you want to move to the right while remaining on the line, you will have to move your finger downwards. Okay, that tells you that since we know that if the line is going down, m is which is our slope is going to be negative. Okay, now here's your next homework which you are supposed to do.